Hi, this is Mrs. Often with some examples on measuring segments and angles. In this, we're going to use the ruler postulate, the segment addition postulate, the protractor postulate, and the angle addition postulate to calculate lengths of segments, values of a variable, as well as measures of angles and values of a variable there. So we're first going to start out with finding the length of a segment. And as we can see, we have a number line and there's some integers marked on the number line. We're going to use the ruler postulate, which indicates that each point on a line can be assigned a unique coordinate and that the length between those is described as the absolute value of the distance between the two endpoints of a segment. So we're going to use this to find the lengths of the following segments: JK, KM, and JM. Now, just a reminder, if you watched my previous video, you should know that JK plus KM is equal to JM. So JK is going to be equal to the absolute value of 12 minus 5, or 7. The absolute value of KM is going to be equal to 27 minus 12. That absolute value will be 15. And then, knowing these two values, we have two ways to calculate the length of the segment JM. First, we could just use the absolute value of M minus J, or 27 minus 5. That would give us 22. An alternative is that we could use that JK plus KM, those two lengths, is equal to JM. And then we see 7 plus 15 is equal to 22. So that's using the ruler postulate as well as the segment addition postulate. Moving on, let's look at these 3 points. We see that points J, K, and L are collinear points. That means that they do all lie on the same line. Therefore, I could name this line, shown here, as JK. I could name it as LK, as KL, or as JL. Now, we are told that the segment JL is 25. Given that, we want to determine the value of N, of JK, and of JL. So we know from the segment addition postulate that 3N plus 5N minus 7 is going to be equal to 25. And simplifying this, we get that 8N is equal to 32. And this means that N is equal to 4 by the division property of equality, or using the multiplicative inverse. We can then use this value of N to determine the length of JK. JK would be 3 times 4, or 12. We also can determine the length of JL. That would be 5 times 4 minus 7, or 13. Obviously, adding 12 plus 13 together gives us the full segment length, JL, of 25. Now, another type of problem, we see here 4N plus 13 in place of 25 for the length of JL. So if JL is equal to 4N plus 13, we can put 4N plus 13 here. And we can write another equation, 3N plus 5N minus 7 equals 4N plus 13. And combining these, I get 8N. 8N minus 4N is 4N. 13 plus 7 is 20. So N is 5. That means that JK is 15. 3 times 5 being 15. 5n minus 7 is 25 minus 7, or 18. And the entire segment we can find either by doing 4 times 5 plus 13. That would give us 33, or we can add together 15 plus 18, and that will give us that the entire segment JL is 33. So that's KL plus JK equals JL, once again using the segment addition property. In these next couple problems, we're going to look at an example using the angle addition property, and one is an application and the other one is just plain angles detached from any sort of real-world application. So in our first one, we have a lighting designer finalizing the lighting plan for an upcoming production. Our spotlight can rotate 25 degrees from the right or the left, and the beam of light from the spotlight forms a 22-degree angle. So here's our spotlight. It forms a 22-degree angle, and it can rotate 25 degrees to the left or the right. We have the chair, the rug, the door, and the table, and then we have the spotlight. So we could map this as having a vertex of S. We have C, R, D, and T. So right now where my spotlight is, RSD has a measurement of 22 degrees. My angle shown here, CSD, has a measure of 57. So that's 57 right here. The entire angle from C through S and to T is 74 degrees. So my question here is, can I light the chair and can I light the table? So I can see just from my diagram that if I have 22 going over to 57, to determine the angle that's left in this part of the diagram, I can just do the measure of the angle CSR is equal to 57 degrees minus 22 degrees. Well, 57 degrees minus 22 degrees is going to be 35 degrees. So 35 degrees right here, that is unfortunately too large for my spotlight, so I can say right away the chair cannot be lit. However, can I light the table? Well, I have a total of 74 degrees. Now this piece here is 57 degrees. 74 minus 57 leaves a total amount of only 17 degrees. So this can rotate through 17 degrees right here, and therefore the table can be lit. So angle DST is just that 17 degrees right here. The table can be lit, so I'll put the chair can't be lit, but the table can. So those are our two possibilities here. We have one situation where if you needed to light the chair, The spotlight would need to be repositioned if you wanted to light the table. The table is going to be all set. Now our next example, we have this diagram shown here. Remember that these two arcs mean that the angles are congruent, and therefore this angle is 32 degrees. Angle XWY, 32 degrees. And because of the markings in the diagram, we also know that VWZ is also 32 degrees. By the way, if I were writing a proof here, I would say definition of congruent angles, stating clearly that these two have the same measure. Now I'm told that the measure of XWZ is equal to 127 degrees. So I'm asked, what is the measure of YWV? In order to find that, that is just this missing central portion, so I can determine that measure by taking 127 and subtracting the sum of the other two angles. 32 plus 32 is, of course, 64, and that gives us a degree measure of 63. So the measure, and notice I'm writing that little m for measure of YWV, is equal to 63 degrees. And just a quick reminder, when writing your correct notation for congruent angles, you can either write that the measure of XWY is equal to the measure of VWZ, or you can write that XWY is congruent to angle VWZ. Okay, so there's some problems for you with the angle addition postulate and with the segment addition postulate and the ruler postulate.